Hello, everyone. Welcome to this new episode of the Swift Academy podcast. Today, I'm very excited to be with Bogdan Poplauschi, who is a senior iOS developer, contributor to many frameworks like SD Web Image and Cocoa Lumberjack. Bogdan also he's a lead instructor at the Essential Developer Program, and this is one of the most famous program for the iOS community and Apple community. And Bogdan now help many developers, senior developers around the world to improve their career, especially using TDD, using solid principle, unit testing, etc. And with his experience, his career help a lot of developers around the world. Hello, Bogdan, and how are you?
Hi, thanks for inviting me. This is very nice of you, and I've been following the podcast for a few episodes, and I really wanted to see more. Like it seems like you are doing some interesting topics, very interesting guests. Yes. I especially liked the episode with one of my, let's say, mentors, which is John Reed. So it was an honor, but also big pressure to come to the podcast after John. So, but let's see how this goes.
You are also famous, Bogdan, with a lot of experience. I was with you in the Essential Developer Program, and I know your experience in different as a lead instructor, and also great contributor to framework that we use daily in our iOS development, like SD Web Image or Cocoa Lumberjack. SD Web Image we use now at Sephora. We use because they have
people still use it.
Great. I think that you are the second contributor in the different with a lot of commits, great commits, and we'll speak about that today. And our topics, it's great topics. It's very difficult topics. Working with legacy code, and I think that you have great experience with that. Working with legacy code, it's a problem for all developers. We can't say that developers that are comfortable with working with legacy code. And today we'll try to tackle this problem to give to our to people that listen to us and see us, watch us, this ability to improve their legacy code, or when they come to the legacy code, can handle this legacy code.
Yes.
That's why there is a lot of there is a lot of books that speak about legacy code. We'll speak about these books, etc. And today we have a great practical part at the end of the podcast with a framework that we choose to refactor some part of the framework in the end of the podcast. That's why my first question: what is legacy code for your point of view?
It's an interesting one, and well, first of all, I think we had many definitions out there, and I think it's starting to shift a bit. So legacy meant something that you inherited from someone, right? That's like the plain English term. And legacy code used to mean code that you inherited from other people, and that most of the time used an older technology or the language,
yes,
or the platform. Is probably like a messy code. So people would call legacy code that. Nowadays, I think it's shifting a bit towards a more hard to understand, hard to change code. At least this is the feeling I have. So I see people, for instance, mention they have legacy code when they have, let's say, a lot of MVVM in their app, but they're a fan of Viper or a different kind of UI pattern. And then they say, yeah, this is legacy code because it's not in the pattern that I'm used to, and it doesn't look like I want it to, or it's not reactive, or
yes,
sometimes even just code that you don't like, I would say.
Yes. Yes.
The other thing is, like, yeah, I think you made a very good point, because everybody's kind of not comfortable working with legacy code. And I noticed that. And it's not just iOS, it's just software in general. Like the harder it is to understand, the older the code is, maybe the more deprecated technology it uses, you kind of tend to run away from it. And a few years ago, I was basically sometimes writing this legacy code and leaving it there for others because I didn't know better. But also, I was not comfortable working with legacy code, and I would usually say, yeah, we need to rewrite that. That's just bad, and I don't know how to deal with it, so I'm going to rewrite it.
Yes.
But later, I had the luck to came across Kai and Mike from Essential Developer, and I started the program first as a student, went to the lectures, then joined as an instructor. And there I was in, basically, that's the place where I found out about Michael Feder's work, which is working effectively with legacy code. I think is basically the top book in this area. There are other books which touch it, but this one is like, for me, the go-to book, which I always use when I'm looking at such systems. And basically, at that time, I uncovered this unique opportunity, which is to be good at legacy code, because everybody is running away from it. So if you are good at it and you can sell this, say, okay, we don't need to throw it away. That's actually valuable. We could use it if we know how to deal with it. To me, that idea posed very, very interestingly, and I spent quite some time in researching, talking to fellow developers, trying to learn these methods, these techniques to deal with that. And I can say that now I'm a lot better. I'm a lot more comfortable with working with legacy code. And some of my recent roles were kind of a consequence of that, because now I'm no longer avoiding this. Right? When I talk to a company, I talk to a team, and they tell me, hey, we have this legacy code, so we don't know exactly what to do with them. I'm not like the 99% of developers who say, hey, I don't want to work there. I actually see an opportunity. It's like, wow, what if I could go there and help these people learn and tame that code? And most of the time, it's not very different. I mean, it is different, but it's not that hard to shape it in a form where you're actually kind of okay with it. It's not easy. It doesn't happen overnight, but I think it has a lot of merit compared to what the alternative is, which is rewriting from scratch, either a module, a class, an app, a framework. And when you start from scratch, you're going to introduce new problems which you don't know. You're going to have to basically rebuild the same behavior which you or your team has spent so much time in building. And I think that is one of the main ideas I took from Michael Fetters, but also from John Reed, that talks about this a lot, is the value of that legacy code. That code works. Users are used to it. It's not something to throw away. It's rather like a resource that we can use if we can shape in a form which we can work with. So that's how I view it. And like I said, it's very interesting. And actually, for people that are curious, there are a lot of katas right now where you get some ugly code, and then you have to refactor it to a better shape. And I think those are really, really cool to do. So if you, I don't know, if you're interested in this topic, check some of these out. They're
like the tribe service from Sandro Mancoso, which is a famous kata to handle the legacy code. The Gilded Rose, I think, so second kata, and you can find that John Reed have a lot of video in this in his YouTube channel about how to working with some kata like tribe service, etc. Which is great. I advise you to watch his work. And from the definition of Michael Feathers, it's a code without tests. And tests is difficult. Test is difficult and difficult for to have, because when we are generally in legacy code, when we come to a project with a legacy code, you didn't have test, and when you have test, at this moment you think, okay, I can understand my project using tests. Tests should be written very carefully, because tests explain the behavior of the code, and that's moment when we come with code that contain tests, well-written tests. I don't think that we can say that the code it's a legacy code. It's great code. It's not a legacy code. It's a great code because we have good testers, unit testers, integration tests, etc. Automated tests, if you can say. And at this moment, we don't speak about legacy code. And
it depends. From your let me make a short point here. So I've been looking at some, let's say, definitions or cases where people put this label of legacy code, and to us, let's say iOS or Apple platform developers, I would say it's a combination of either the old languages like Objective-C or even C, right? Old technologies, for instance, SQLite instead of Core Data or Swift Data. Or how we used to do it a few years ago with UIKit and manual frame calculations. Perhaps that's how the UI is done. But also handling the complexity and the logic of the code. So with poor naming, with duplicated logic, which is spread across many files, with very complex logic that is so hard to understand, with mixing concerns, right? That's basically textbook definition of what we nowadays call a massive view controller, which has UI, networking, persistence, synchronization, threading, and so on, right? And at the end of the session, we'll see a code, an example that kind of falls into this category. But also, as you said, code that has no tests or very few tests or maybe bad tests, right? So people that try to write some tests on them, but they couldn't. So now it's just tests are not useful. Also, low cohesion and high coupling between components, code that's not modular, code that is not properly encapsulated. And these, I think, some traits can be some traits of the right. Some traits of the code. So it's not always tests, and tests don't always guarantee that that code is good. And good, I think we have fallen into a bit of a trap in software development where we can say this code is good and this code is bad. Like I'd avoid thinking in these in these terms.
Something is related to our ego. It's related to our ego and arrogance sometimes, And when we come to the when we come to the project, and we say, no, it's bad. Everything it's bad. We need to change to change everything. It's a legacy code, and at this moment, you can have a lot of problem with the business because this code it's paid with a lot of money, etc., and it's work. It's work. It's in production now. How you can convince people and the business that this code it's not a good code at this moment because it's in production. People use the application. There is no comments. Maybe the application have a good comments in the store. We don't know. that, but when we come to understand the code, etc., you find that it's not easy for you to find. At this time, maybe you can think that you didn't have the level to understand this code because I find that a lot of the developers come, the code is very hard. I can't understand this code.
Yeah, that's
maybe
it. That's it.
It's related to your level, to your seniority in Swift or in other language, etc. In the framework that you use, and this is very difficult for developers. And when you say that it's not only tests, there is other traits, traits to say that the code it's not scalable. There is a lot of problem of modularization, a lot of cohesion, a lack of cohesion, and a lot of coupling between component, etc. And tests, they help us. They are not the only traits to say that the code is legacy. And
yes.
for that, for your point of view, what are the challenge that come in refactoring Swift code? And first of all, I think that the definition of refactoring and rewriting code, it's really, really difficult for developers to distinguish between refactoring and rewriting code. What is your point of view?
Yeah, so a few points here. First of all, yeah, I think that's what you said. Not understanding the code, which means changing the code, is hard. I think that is like the core issue, because legacy is not bad because it's just a timestamp you like a stamp you put on your code base, right? It's just like, yeah, it's legacy and it's bad because other people tell me it's bad. No, it's because your team sees that whenever you try to change the code, you either spend a lot of time changing it, adding features takes longer and longer every time, or you get a lot of defects because you're changing one thing and you're breaking 5 others.
Yes.
So that is usually like the sign, right? When you're dealing with that, and it can lead to a lot of actually to a lot of mistrust. So then developers, you naturally say like, oh, I'm never changing that because I don't understand how it works. Yes. And I think you made a good point. So sometimes with seniority, with experience, you can understand code better, but even then, the mental model you can represent in your mind is can do so much, right? So at some point it's like, hey, I just can't deal with this. I don't get it. And that is how refactoring was invented, basically. Yes. To put the understanding you have in your head about the code in the code. So then you don't have to have this kind of a mapping where I'm looking at a variable and it's named I, and I know it's the index for the list of prices.
Yes.
Or currencies, right? It's like I name it index of currencies, and then next time I look at it, I have a bit better understanding of that code. So yes. That's what refactoring is, to transfer the understanding from your head, from your mind into the code form, right?
Yes.
So I wanted to make that point.
Yes, and
also,
yes,
to finish this idea. So
okay.
I think many smarter people than me said before that an important value of the code is how easy it is to change. So easy to change code allows your company, your product, to move faster, to adopt newer trends, to respond to user demands, to do whatever it needs to do, right? So if you can maintain that good rhythm with refactoring, with cleaning up, Kent Beck has recently published one of the books in the series of tidying up. So I really like this term, like tidy up. It's a bit better than cleaning up. It's like, it's tidy, right? Tidy. So I like it. It stuck with me. Then that's when you can bring a lot of value. So, and again, understanding the code, you make less mistakes, right? So I think that's why it's very important to deal with this. And like I said, it's either the case where you're in control of the changes that are happening to the code, you and your team, and then you tame these, you make a balance between adding new things and tidying up, so it's always in a okay shape, not necessarily ideal. Or how it gets to legacy code is the tech debt, the areas which are complex and hard to understand tend to build up. And then, like I said, you're afraid. It's like, I'm not touching the user manager again because it has 3,000 lines and it deals with all kinds of stuff. So I'm not touching that. I'm not refactoring it. And then every time you put more code into it, you're trying not to touch what's in there, and then you make a bigger mess. Right. So that's how it accumulates. And at some point, somebody says, hey, this no longer works. We need to rewrite it.
Yes.
So back to, that's how I kind of transition to your question. So to me, like I said, rewriting is such a risky move. It's sometimes the right move, but I don't want to talk about it until we also talk about, okay, can we transform this existing code? Is it, first of all, is it doing what's supposed to be doing? If yes, then I'd rather refactor it with techniques. It's going to take less time. It's going to be safer. We can keep delivering other things in that time. And we'll end up, if we do the basic thing, which is refactoring. Refactoring means not changing the behavior of the code. This is super definition. Important.
Yes.
You, myself, everybody's had colleagues, ourselves maybe in the past, we say, hey, I'm going to refactor this, and you just rewrite the class. Like, that is not refactoring. That is rewriting. It's very risky. You're doing many moves, steps at the same time, and hoping to land in the same behavior as before. Like, that never happens. Because every subtlety, like a thing being optional or not, a collection index starting from 0 or 1, everything, every little detail changes the behavior. So if you've ever done test-driven development, if you've had like a proper suite of tests on a code, you see how easy it is to break the test, which basically means you change the behavior.
Yes.
Sometimes just changing the order of 2 lines of code changes the behavior because there's temporal coupling there. So that's why some smart individuals, starting with Martin Fowler, thought, okay, we're professional developers. Let's make this thing, refactoring, into a organized process that has defined steps, not like all over the place, not the state where I say like, leave me alone, my project will not compile for 4 hours until I'm done with this. Like, not that, the opposite. So concrete steps, things to look at. And that's why, for instance, to me, another great book is Martin Fowler's Refactoring, which is kind of a manual on specific refactoring recipes, which are very concrete. Like, now I'm doing the extract method refactoring. Like, it has specific steps. You do it in a specific order. You check things. It reduces so much the room for error, right? So that is why, first of all, understanding the concept of refactoring, which is I have the behavior. I like the behavior of the code. I want to preserve it. I'm going to make tiny steps to change the shape of the code to preserve that behavior. That is basically what you want to do with refactoring. And it comes also as a step in the TDD cycle, right? But let's not go there, because I think I saw some posts from John Reed recently where he was saying, like, there's very few TDD iOS developers out there. So let's not talk to that niche and talk to like, okay, refactoring is something you might be doing in a project. It's fine. It's just try to understand what it means and try to use it as it was designed, so it's safe, so it doesn't break. Because every time, imagine this, and I think I had this conversation a few times, you see an improvement to your code and say, hey, if we make this improvement, we're going to develop faster, it's going to be safer, it's going, whatever advantages you're seeing. You do it. Maybe ideally you communicate with your team, like with your manager, with your product owner, and everybody's like, yeah, man, do it. It's like, yeah, we want to get better. And then something breaks out of that refactoring, out of that improvement, let's call it, because it's not a refactoring, right?
Yes.
And then what message are you sending? Is like, I cannot handle this. Whenever I'm going to say I'm improving things, I'm breaking things. So next time, everybody in the team is like, hey, are you actually sure about that change you're making? Because, last time you just broke, purchases for 2 days.
The same. When we spoke in our first meeting, you and me, about that I faced the same thing, because I make a rewriting of something very important, which is the deep link architecture in the application, using a strategy, pattern, etc. It's a rewriting. It's not a refactoring. It's a rewriting with the good patterns, with more testability, etc. And at this moment, I skipped one case, and people say, business don't see the all the good things that we made our team, but this, you break the code in production. You break the code in production because you have missed this particular case, and for business, they take money. It's a lose of money, and it's important to be carefully to do things carefully, to do refactoring instead of rewriting. And that's why I appreciate your definition, and this, how you distinguish between rewriting code and refactoring code. Because refactoring code, as you said, it's to keep the behavior, not break the behavior of the code at production. And we have, there is other techniques to make refactoring. Begin by, as you said, little baby steps of refactoring. Come to a function which is a large function to create a more little number of line refactoring, or make 2 or 3 functions instead of have one functions. We have tools like Xcode, IntelliJ, etc. Tools that make this thing very, very easy, using Xcode or AppCode or IntelliJ, any tools that help us to do this. And our language, which is Swift, it's a language that help us. It's a statically language that help us to make refactoring and much more easy. I don't know that you have other example of idea of strategy, how to begin with some baby steps of refactoring. If you can continue with this idea of strategy of refactoring.
Yes, of course. But very good point. I totally understand your example. I liked it the first time I heard it now as well. So basically, breaking one of the deep links of the app is usually a bad thing. So it's not recommended, right? Even though there might be a lot of benefit, like you said, testability and things like that, but behavior is so important, especially as you're building up, because every app keeps changing. It doesn't stay the same. So it's very important to try to preserve that behavior, right? Like you said, refactorings can start from the IDE ideally. And I know, for instance, John Reed was a big fan of AppCode, which is the IDE from IntelliJ that is kind of deprecated right now. So I don't think they're going to support it. That
Since
was a really good tool because it has all the IntelliJ refactorings like extract, separate, move up, move down to class, extract class,
and support TCR also. Support TCR, test commit, test revert, etc. using AppCode, which is a techniques. Maybe we have time to speak about TCR in refactoring.
TCR is a bit extreme, but I like it as well. But it's very hard to sell.
Yes. We keep yes.
Yeah. Okay. But even because I think a lot of people are using Xcode, right, for development, and Xcode has basic functionality like extract, method, rename, things like that. It's not always working because of the indexing and stuff like that, but it's still acceptable. So why are we talking about IDE? Because if the IDE has a built-in refactoring that it can check based off in its interpretation of the language, in our case Swift, but can also be Objective-C, then it's much safer because they already do the checks that need to be done in order to make that refactoring happen. Whereas when you do it manually, like we did it years ago when Xcode was just a text editor, or with other editors, then you have to make all these verifications manually. You have to be more careful. So it's always safer to do these refactorings with the IDE if the IDE supports this. Right? And I would say there are many, and you can check Martin Fowler's book, as I said, but the most basic ones are the ones I use the most. So let's say rename variable, rename function, rename class, extract method. So you have a line like a method with 100 lines. 10 of these lines do something which you know, because you maybe wrote the code or just looking at it and say, hey, but out of the 100, these 10 lines are just, I don't know, sending a notification. So you extract that to a private method and you call it send notification. And I don't know if you can find a better name, because naming is a very interesting topic, and there's so many principles, and you can take it so far, but it's so beneficial because if you find the right name, and it doesn't come always first, so naturally you have to iterate a bit and understand the code better to name things better. But if you get the right name, it's so much easier to understand that code just with a slight change of the name. So these are the ones, and Xcode already supports this. As we said, there are more advanced ones, but I would start with these. And great point that you made. Swift being a statically typed language, it can help a lot, right? So it's checking types, it's making sure you're not passing a nil where there's a non-optional type wanted. It's kind of rigid in that area, but also safe, right? I was recently refactoring some fast file, so fast lane configuration file, which is written in Ruby, and Ruby is not type safe. And it was so hard because I had a lot of trouble checking that, and I actually end up writing some Ruby tests for it. But again, like the compiler did not help me as Swift does. So
or
it
Kotlin
was
Okay, it's great. Strategy of refactoring are great, but how we can detect code smells? Because we have a legacy code, but we have some strategy, but how we can detect what we call code smells in the legacy code, and after that make changes with refactoring without breaking behaviors? What kind of tools or strategy to detect or to identify code smells?
I know there are tools. For instance, we've used at some company, I think we use SonarQube, and there's a bunch of other. Xcode static analysis might be one that's at least doing some basic stuff. So it's never a bad idea to have that run, maybe in a CI pipeline or something like that. Make sure at least the basic ones are caught. I know SonarQube, and there are some other tools similar to that do automatic detection of some patterns like smells and things like that. Usually I just use my experience by looking at the code. That's kind of how I detect it. And I encourage everybody in my team to do the same, which is to read the code and see if it's something doesn't sound right, or something is complex, or you don't understand how it works. It sounds, maybe it looks magic, and there are some, let's say, patterns that you recognize. I recognize in a code, and immediately my mind starts to send signals like, hey, this could be improved, this is risky, and we might talk about this. But usually it starts from this, like, hey, this is complex. I'm looking at the code, I'm looking at the interaction of a few components, and I feel the need to draw a diagram to understand it, or I feel the need to write tests, which is something you can do if you know how to write tests, is to write tests to understand the code, which is kind of interesting.
Yes.
Because then you do. No, I'm not sure if I want to open this door without explaining properly, but in the book by Michael Feathers, Working with Legacy Code, Michael talks about some kind of approval tests or characterization tests, which I think that's the name he uses. Other people call it approval tests. Yes. But these tests are not unit tests. We run the code, we see what the output is, and we put that output as an expectation. So we don't know what it does. I just run the code and see whatever it puts out. Right? That's how you usually write these tests. And again, I encourage you to dig deeper if you want to understand, because it's kind of hard to explain this in a podcast.
Yes.
But that's the idea. So understanding the code, that is where we left from. Because most of the time, I think there's some statistics on this. So we basically, as developers on average, read code a lot more than we write code. So when you read code, you have to understand it, because you're probably looking for some way to change it or to add something to it. So then it's very important that the part where you understand the code happens quickly and rather clearly. So it's no ambiguity there. Right? That's an effective state to be in, which is not the case with legacy code, right? Yes. So let's talk about some concrete examples. One which happens to me a lot, and I always have a red flag when it happens, is like, I have to make a change, and I make the change in a file, and now I realize that either the compiler or at runtime, I see that now I need to do the same change in other places which look the same.
Yes.
So it's kind of duplicated, but I can in theory change it just in one place and leave the others. Maybe, or maybe not. Like I said, it depends if it's a compiler issue or a logical issue. But that is like a big flag to me, say, hey, this is duplication. This is risky, because now, instead of being one component that is dealing with whatever concept it should be dealing, that's spread across I don't know how many files. And then it's up to me or to other developers to apply the same change everywhere. And that is error prone, right? Sometimes that code is kind of the same, but not always the same. So now I need to stop and decide, like, okay, how does this fix apply here? Because that code is not 100% the same with that code. And it can become very, very complex, right?
Yes. Yes, great.
That is one example.
This is a great example. And
another example would be global state. And by global state, I mean even singletons, everything that is accessible app-wide. And worst case is when this global state is mutable. So I have a singleton maybe, or just a floating global variable somewhere, and now I can, from 5 places, I can change that, set it, and other components react to that state. To me, that is like
code smells.
Code smell, which means there's threading issues there, because usually that data is written and read on different threads.
Yes.
As we know, most of the time we run things on multiple threads, even in iOS apps. So that's immediately a smell and a risk there. But also the problem of no encapsulation, no separation of concerns.
Large classes.
There's just a dependency to something, and it's hidden. That's the problem, because when you look at whatever component is using that global dependency, you don't see it in the header, you don't see it in the interface. It's just used somewhere, and that is like a surprise. And to me, another smell, if you want, is surprises. Like when you're reading code, when you're looking at code, you shouldn't have any surprises. Things should feel natural. So if I have a function that says save user to database, it should not send a notification. It should not write to, I don't know, a different storage, a different object, or read, or whatever. Like, that's an example. Like surprise. So I don't like, I like surprises, but not in the code. So when you code, it should be very straightforward.
Yes. When you are, for example, in a view controller, you didn't try to have networking, persistence of data, threading, something okay, we accept sometimes analytic, etc. But when you are in creating only user interface, you try to have this single responsibility to writing user interface. When you are to try to make call to an API networking or persistent data, you should be in the right component that his job to do this, not in the controller or in the view model or in the presenter, etc. And at this moment, you try to make, but it's not easy, because you try to don't break the behavior. Always in your mind, this idea to not break the behavior. We'll find that in the practical example.
Yes.
In the end of the podcast.
Yes. And but let me expand a bit on your idea, because it's a very good one.
Yes.
So view controls, right? We see these view controls that are mixing concerns like UI and threading and database operations, and not necessarily database, like any persistence, user defaults, whatever you want, networking, like you said, and analytics, and maybe login, and just so many things. And I think that is why these components are so hard to understand, because every time we add one of these concerns to them, the complexity increases. So you look at that code and say, well, this is legacy code because I don't know how to change it. But if we just separate these into different components, it's already a much easier to understand, to work with code. So yeah, that's one of the top ones when I see different concerns mixed in the same entity, in the same file, in the same class. It's an immediate shout like, hey, this needs to be broken down, because it's not going to be testable. It's not going to be easy to understand. It probably has some hidden bugs which are hard to see. And it's just like, I don't care that much if it's stateful or stateless, or if it's using MVVM or Viper or TCA or something. I don't care. It's just like, are the concerns separate? If yes, then that code is 5 times, and I said 5 as a random number, easier to deal with, no matter the patterns you use near it. So yeah, that's a big one. Seeing these mixed responsibilities, and in a view controller, it's rather easy to see them, because I mean, if you know that view controller should only deal with the UI, everything that's not UI should not be there. But there are other layers of the code where these mixing of concerns are not that obvious. So for instance, if you have a component that is doing networking, and they also do, when they get the data response from the network, they also do parsing with JSON serialization or codable or whatever they use, you don't see a problem there, because it's like, yeah, I ask for an object and I get the object from the network.
I accept that.
Right?
Yes.
Right.
Yes.
So that is a bit harder to understand. But again, it's mixing concerns. And if you look at, I know, high level to low level modules, they belong to different levels. So networking is more low level than parsing. Right? So they belong to different layers. But that's more subtle than having networking in the UI view controller. That is just super obvious.
Yes.
Right?
Yes.
And so very good example.
Yes.
Just to wrap my list. So we talked about duplicated logic, global mutable state, mixing concerns, like we said with the view controller.
Yes.
I would also say smell very large code files. So whenever you have a large file, 1,000, 2,000, 5,000, whatever lines of code, there are some issues there. Most probably because it's so hard to write good code that gets to that size. So there's no separation, probably there's mixing of concerns, there's all the problems, right? So again, that's a smell. When I run and sometimes I do that when I have to look at a code base and make an analysis, I start from a basic tool that is counting the lines of code in each file and highlighting the biggest files. And then like, okay, I have some understanding of what are the bottlenecks. And those are usually files where a lot of developers are touching. So if you look at, let's say, the number of commits made in a year or in 5 years per that file, there are many, right? Because everybody is going there and adding or changing. So those are also bottlenecks for Git conflicts, right? Yes. So if you separate these files into more clear responsibility, smaller ones, you also reduce the number of conflicts you get. Because if I'm just, let's say the example with networking, right? If you have to work on the networking layer and I have to work on the mapper, if they are in separate files, there's no problem.
Yes.
If they're in the same file, then we get a conflict and we start to like, hey, what has Valid did here? Like, I need to understand what you changed, or you look at my code. So
yes,
again, but the smell is just the size, right? And I'd also mention having many optionals. There's domain-driven design, which explains a lot of concepts. And I encourage you to read on that Eric Evans' book, and there's some other great books on that topic. It's not an easy to understand topic, but what we can take from there as a low-hanging fruit is representing states in our code. It's important to represent states that are possible and not allowing the user or the developer to represent states that are impossible. And Swift as a language also helps with that. So we have enums with associated values, we have non-optional types. And where I'm going with this is, for instance, I see many developers that don't really understand how optionals work. So they just optional everything. Like everything is an optional or implicitly unwrapped optional.
Yes.
And then you basically allow the system to represent, you allow the developers to represent types, values with optionals that should not be optionals. And then when you work with the option, it's like, but what should happen when this is nil, right? And it's just a bad situation to be in, right? So I also look at this, and when I see like a lot of optionals in an area, or a lot of, let's say, booleans, right? So if you have 3 booleans, that's 8 cases in total, right? Yes. With all the combinations, but maybe they're just 3 real cases, because if the first bool is true, then the other ones cannot be true, or something like that. I don't know, like, yes, just imagine an example, right? So yes, then you can represent that with an enum which has 3 states, and then you cannot put the system in the state where these are set wrong, right? So that is also, I would say, both optionals and representing data concepts from domain-driven design, is to try to use the compiler to represent only the states that are possible. So that sometimes means talking 3 minutes to a colleague, maybe when you pair program or when you have a, I don't know, meeting, is like, yes, should this be optional or not? And at first it can say, hey, we can't spend this time talking about an optional, but they add up. And it's so much clearer when you go to a class and, let's say, I don't know, like a basic case, you have a view controller and you have a view model, right? If the view model has to be passed through the initializer, and there's the only way to construct that view controller is by passing a view model, then you basically helped everyone in the system know that, hey, you cannot create an instance of the view controller unless you pass a view model. Yes. So that is representing state. If you just put the view model as an optional property, then you kind of have to deal with both states, right? And that can multiply to thousands and thousands of cases across the app. Nowadays, apps have so many cases, especially with A/B testing, with feature flagging, with yes, not to mention optionals and things. So it's like crazy. You just can't think of all the cases you need to cover. So this one is also important, but I would say maybe at the lower part of the yes, of the list. But yes, these are the main ones. Yes, I think that we that you cover a lot of code smells in to detect when we come to refactoring. We have it depends also for the experience of the developers, etc., seniority of the developer to detect these code smells. By the time all the teams, I think, should have this experience, especially when we come to code reviews, etc. And when we are in code reviews, we can share this experience to detect the code smells and to improve this in other commits, in other pull requests, if you can say. Great. We can detect now the code smells, etc. We can move to another topics with refactoring, which are refactoring strategy. For your point of view, what are the key strategy or pattern that we can use to refactor Swift code, and how we can prioritize what the refactor first in legacy code, because it's very difficult to detect which is the first part that I can begin to refactor, especially when it comes in great code with great number of files, of classes, dependency, yes, etc. How which one by which one part can we begin? This is the question. Yes. So yeah, it can be daunting. I yes, give you that. Yes. I tend to start with the parts that we need to change. So instead of going and say, hey, I'm going to start with the app delegate, or no, I'm going to start with object, like some models or something. I'd say, like, start from the code that you need to change. And usually for me, it's like this. I need to make a change. Of course, you look at the code and it's like, where do I need to make this change? Where kind of around these classes or this method. Okay, is this code clear enough? And if it's not, then I try to refactor it a bit, just to, like I said, to express my understanding. So I spent like 5 minutes, 10 minutes looking at the code. I understand it a bit better. And now I try to put this knowledge back in the code name. in the code structure, right? So it's the next person that comes after me can spend 2 minutes instead of 10, maybe. Ideally, as Michael Feathers explains, changing code that you don't understand without tests is very risky.
Yes.
And the whole book is about how to... This is tricky because sometimes the code is not testable, so you can't test it. You can't write tests until you change it, but you don't want to change it because you don't have tests. So you're kind of in a loop here. So to break the loop, Michael Feathers recommends that you make some very, very small changes to enhance testability. Then you write these characterization tests I was mentioning.
Yes.
And now that you have some coverage on that code and you know it does what it needs to do, you can preserve that with the test. Then you start to change it a bit. That is like to me, the ideal scenario. Yes. And when I can, I follow that. Sometimes you have to go in and it's like, I don't know, you come into the office, there's a big incident in production, there's a crash or something that's not working, and you're like, hey, we need to make a patch now. You might need to go in there and make the fix.
Yes.
Without having the chance to write these characterization tests and everything.
Yes.
I mean, it depends on how sure you are, because if you're introducing a bigger issue, then that's not okay. Yes. But again, it's something to consider. But let's eliminate that case, because then you that probably doesn't happen that much. And it's also like you're going to deal with it differently. You don't refactor when there's a fire burning in your team, right?
Yes.
So when it's not, like I said, just making these small steps, if possible, writing the tests. I tend to do that most of the time. Of course, the more complex the code is, the harder it is to test. If it's dealing with threading, if it's dealing with I don't know, many dependencies, many frameworks, things like that, it's harder to test. But sometimes you can do it, and there are techniques. There are great techniques in the book to do that. Yes. So that's basically what I try to do, because the more I understood these principles, the less I'm willing to start to change code without knowing what I'm doing. So I used to, and as others have used to, go in there and say, hey, yeah, I know this code, I'm going to change it. I'm fine. Like no test, no nothing. Now I'm no longer confident to do that, because I know how easy it is to break things. And I don't want to be the one that has to report, to fill in an incident report and sit with the management team in a meeting and explain why it went wrong. I don't want to be that person. I want to be the person that is reliable and like even the QA in the team know, hey, when Bogdan is sending something to us, it's probably good because he has done the due diligence, added tests, made sure the behavior is covered and things like that. Of course, mistakes happen, so it's inevitable. But I'm trying to reduce the probability to a minimum.
Yes, to keep this good appreciation from the management of the QA teams. It's important, because if we have this good appreciation, we can move on in refactoring, maybe rewriting the code, etc., because they have some trust on us. Which is important to have this trust on us, and maybe to help us to have some of roadmap in the future to make better improvement, etc. Because by the time we have this ability to understand more the code, etc., how things works, when we have this ability to make tests, etc., and to improve our because it's important to have this ability to write tests and detect also the dependency that we should mock, etc. We'll find this in the practical part. And as you say, it's important to keep this confidence to our work, and also appreciation from the other teams when we come to legacy code, because developers I think that they forget that. They come to usually to code, working, rewriting code, etc., without thinking about the impact of their rewriting code or their refactoring in the for the customers, etc., for the company
yes.
that they work inside.
Yes.
Great.
But let's yes? Make a point here. So
okay,
thinking like a developer. So there are a few cases here. And the first case is where you know how to run tests. If you know how to write tests, awesome. You're in a great spot. Go in there, write tests, then refactor.
Yes.
If you don't know how to write tests, and I think that's a majority of developers, at least that I know. Like maybe I have the wrong set of acquaintances, but I don't think that's the case.
I think that I can confirm.
So if you don't know how to write tests, you can invest in learning how to write tests by taking a program, by
reading books about unit tests. Yes, there is
talking to your team. Hey, let's learn this skill. I think it's gonna be useful. Let's put a plan together. But you can't wait to gain this skill. And if you want my understanding, my experience, learning how to write tests is one of the most difficult skills you can get because there's so many levels to it. There's how to write tests, not to couple it with the production code, how to keep tests easy to read, agnostic from the structure code. And testing on the behavior, how to name things. Like the testing is a complex matter. How to write tests for code that is not testable, how to make isolations, things like there's many things and many strategies. How you write the proper, how you create the proper test strategy, because there's unit tests, there's integration tests, there's UI tests, snapshot tests, all kinds of tests. So how you mix these up, like there's many levels to it, right? So it's huge if you get these skills, but it's not something you get easy. So then I would say, okay, if you're in that spot where you don't know how to test, then you can still refactor, but in a more safer way, right? So first of all, we mentioned IDE refactorings. If your IDE supports a refactoring, I think you're kind of okay to do it. Renames, extracts, like extract method, extract class.
Yes.
Those things which are safe, but renames, first of all, if you just look at code and improve the names everywhere, that's a huge benefit. Let's say up until you learn how to test, up until your team is more confident. So I would start there. Like a lot of inconsistency, a lot of problem come from naming, not from not knowing how to do, I don't know, Uniflow pattern and more complex things. It's from the little things. So you can still do them. Ideally, like I said, with the IDE, if not, do it by hand, but be very careful and try to understand that, okay, I'm trying to preserve the behavior. So understand this idea of refactoring and try to keep the changes just to that level, to that idea that you're trying to make without changing the behavior.
Yes.
So if you do that for 6 months, the code will be in a such better place, I think. At least that is my experience.
Yes, so we'll speak about your experience later, about your real experience with that, with your colleagues, your teams, your team, and from real world example that come from you. And I think that testing, yes, it's very difficult topics, etc. But we need to learn. And I think this is the problem, because developers come, okay, testing, we know some simple principle, red, green, refactor, etc. But when we come to practice things with legacy code, we have this. We come to, I don't know with the term, with the reality of things.
Yeah.
Because when we begin with some programs, etc., books, maybe the example it's not cover all things, and they are academic examples. They are not real world example, etc. For me, the best mentor, it's the team, the seniority of the team, and some people that can help you to go further with with testing. Okay, but you need also time, because a lot of developers think that after 1 year or 2 years it will be a great developer that write good tests, etc. No problem, come with legacy code. It take time. It take many years for me. It take many years. It depends of the intelligence of the developers, of the time that they take to learn testing and to watch video, etc. Paid money to be mentored by good developers, etc. that have a lot of experience with testing. Go and have this confidence and this experience and this passion to go to make things in the real project, and you should have this confidence. I think that the confidence is important, because people, okay, they learn from sample example, from example that come from programs, etc., to mentoring programs. But when we come for the real project, they didn't do anything. They are stagnant, something like that. And I speak about testing. No, I know how to write testing, but when I come to my project, my daily project, which I spend at least 8 hours per day, 8 hours per day to work on my real project, I didn't make tests. At this moment, we can't go with legacy code. We can't speak about it's a question of psychological problem for me. It's something related to psychology, to confidence, to the something related to our, especially in mobile developers, because in backend I see that people make tests, etc. They have a lot of confidence. They make to API. I know that there is teams with 100% of coverage. I don't say that coverage it's the only parameter to say that we have a good code, etc. But it's one of the parameters. Know that code coverage is not it's not the only parameter to say that okay, we have a good developers, or good code, or good scalable code, etc. It's important to make this step forward, to go to learn, to take the time to speak about with great developers, to watch podcast, video, etc. that speak about testing. But the first thing is to practice it in our real project, our daily project. When we practice in our daily project, and that's the thing that you do with your colleague in your teams, at this moment we can say, okay, we have experience with refactoring code, we have experience with testing, etc. Everything else for me, it's like lie, like something that it's not solid, if you can say.
No pun intended with solid, right?
No.
Oh, yeah, that's true. Yeah.
Yes. I think that we can go to because we speak about best practice tools, etc. And when we come to legacy code, we try to think about scalability of our legacy code. How we can improve by refactoring the scalability of our Swift code base, or Kotlin code base, every mobile code base, language code base.
Yeah, so scalability is definitely an important parameter, as you said, an important metric.
Yes.
To consider, but it's so hard to express because it's volatile, right? We can sit here, both of us, or with other folks, and talk for an hour if a specific piece of code is scalable or not, and we're not gonna reach a conclusion because it's very, I don't know, it's like an abstract idea, right? But to me, to simplify what I understand is like a scalable code base is a solid code base, and I mean that by the acronym SOLID, which means following the solid principles, and basically scalable means easy to change, easy to understand, easy to change. If the code is like that, then I think it's scalable. Of course, we can debate about other traits, but to keep things simple, I would say this is the important metric I try to keep. And what I noticed when I started studying other developers, okay, what are the top developers doing? And for that, I need to go outside the world of Swift, and because there are great Swift developers, but I wanted to take a look at other developers as well, which don't write Swift. So I see their code, and I try to do the same. It's very simple. You look at the code, it's like, hey, this is incredibly simple. Like, where is the magic? And that is the magic. That is the skill where the code base is scalable. When you have these tiny pieces, every one of them is simple, is clear, is named properly, and they're just mixed together in an architecture. And that's the product, that's the application you have. So I've seen this across platforms, across languages. The best developers, in my opinion, write code that is very easy to understand. It's almost like a trick, because when you start as a junior, you also write simple code, at least in the very beginning, and then things start to get very complex. But I think that's, to me, that is the I don't know, like the
writing
the holy
simple
grail
codes for
of
difficult
development.
Something like sorry to interrupt you. The difficulty is to write simple code for complex behavior.
Yes.
This is the seniority.
Because it's
writing
very easy.
Simple code to handle complex things. Because show, list, etc., in table view, etc., junior, senior, etc. But when you have complexity and you try to read simple code, this is the seniority. This is the when you to keep that, it's very difficult. Right.
Yes, and then once you do this, then there's more levels. Like I said, there's the design of the system, the design of the models. There's all the design patterns, which can be very useful, and there's a place for them. It's just that I wouldn't start with that, right? So sometimes many times when I'm refactoring, when I'm improving code, I'm not trying to follow pattern, and I'll explain why. I try to see exactly what the code does, and we'll see this in the example, in the practical example, where it's just like, okay, I try to express what the code is doing. I'm not trying to fit this into one of the patterns. I'm not trying to do anything magical. And the value which I see here is that every colleague of mine, if somebody new joins, if we have junior people in the project, they will understand it. If I just do decorators and strategy pattern and like all the, I don't know, redux for representing state and all of that, like they will have some issues understanding that. And they will come to me. So then I cannot work because I have to keep explaining to folks why I implemented things in a certain way. So again, that's why I said with scalability is also being able to, like, one vertical is adding more people to the team. So does your code base scale? And if it's modular and if it's easy to understand, and it scales because you can draw lines between your modules and then you allocate different teams to work on them. That's one aspect of scalability. It's not always adding more features. It can be adding more people to the team. It can be adding more languages. It can be, I don't know, supporting more devices. And there's many, many verticals that we can talk about here. But I think it's all down to how well you understand what you have, because then you can change these verticals. You can impact them, right?
Yes, it's great. It's great. Now to the last part before we can go to the practical part. It's from real world experience of Bogdan with refactoring. Can you share one of the example before we go to the practical part? Because I think that me and you are trying to go to this practical part, because we try to show people how we can do things, because people who watch us
we have
or
to
listen
walk the
us,
talk.
yes, try. Yes, okay.
Yeah, I mean, there's many examples in my career where testing, where refactoring made a difference. I'm gonna talk about one of them, which I'm really proud of. There are more. So basically, at some point in my career, I joined a team of two. So they had two iOS senior developers in the team, which basically was a legacy code base they inherited. So they didn't create it. Both of them are seniors. The people that created the code base are gone from the company. And a few months after they joined, myself and another colleague joined. And now we're four developers, all senior. And this was before I really learned about testing and about how to deal with legacy code. So we kind of tried to do it empirically. So we said, okay, we need to write tests. We understood that we need tests to cover this code, and we need to, over 1 year, we said we need to improve this code because it's hard to work with. So our strategy was to, and basically at that time we had like under 10% code coverage or something like that when we started. The two guys that came before us started to write some tests, and we had a framework for UI tests as well. So basically what we decided is like, for 1 year and more, but we measured for 1 year, everybody will be doing everything that they can to improve testability, to improve the design, to improve coverage. We're gonna deliver all the features with tests, every bug with tests, because that is an important point which I forgot to mention earlier. So to me, it's very valuable when you find a bug to first write a test that proves the bug exists and then fix the bug. And then you have that test, automated test, in your test suite, and you are sure that it's not going to regress, I don't know, in the future. So we did that for tests, for bugs. We did that for features. And we basically had just one QA we were 4 developers on iOS and 4 developers on Android, and just one QA. So it was no way this great guy could have covered testing for everybody. So like I said, our strategy was everybody will test their own stuff. And in the meantime, we had to make some refactorings to enable testability to some of the components. And we started digging at it. And it was great to see just things improved over time. And I think after the 1 year point, we were around 70% code coverage, real coverage, because we talked about how code coverage is or is not a real metric. It needs to be backed by assertions. So if I change the production code and the tests still pass, then that is not real coverage, because I need to know that something was broken.
Break. So from the production code, if the production, it should break the testing code. If it didn't break, something is strange in our testing. Yes.
Yeah. So just to wrap things up here, I think this is a great story. What happened as we increased this code coverage is we got more confidence. We learned how to do things, how to make tests, how to write our code so it's testable. We didn't do TDD. We were writing the tests after we were doing the implementation, but before we merged anything into our main development branch.
Yes.
which is, now we know, less than ideal. But again, at that point, we didn't know how to go into TDD, but we did that. And even with this, let's say, pragmatic approach, so we didn't take the most pure approach, which is TDD. We took this approach where we wrote the test after. We got a lot fewer defects over time. We had a lot of confidence in the releasing, because once the test at 70% coverage, and that was covering most of the important features of the app, if the test passed, we were like, okay, ship it, like great confidence. The QA was just helping us improve the test suite, so they were no longer doing manual regression tests over and over and things like that. And I can say a lot of good things about this setup. The one that really impressed me was, unfortunately, when the pandemic hit us, this company I was working for was really affected, because they were in the entertainment industry, and basically no more income for them. So to make the story short, all the 4 iOS developers on the team at some point left. So there was no one from that group that stayed with the company, and they brought in 2 junior developers afterwards, somewhere. And this is the part which really amazes me. The 2 junior developers, which were new to the project, so they could say, this is legacy code because we don't know anything about it, kept the same release cadence, which was 1 every 2 weeks, as we did, because they had the test suite to back them up. So it's almost like having the team there and say, hey, this is wrong, fix it and everything. So that just, to me, maybe I'm biased, but to me that proves that we built the suite to such a degree, and it was so helpful that the company didn't break operations when they had to let us go, because the infrastructure and the test suite was in a really good place. And I think for a business, this is huge. I mean, of course, businesses don't want to lose their teams, right? But the idea that no one is essential there, because the code is self verifies itself through the automation suite is just amazing. And like I said, I was just a beginner in testing work back then, and it's still one of the teams I really loved being
great experience
part of that.
Great experience with the developer that increase in their seniority with legacy code. They have a lot now experience with going with legacy code, writing, testing, etc. And maybe these junior developers with 2 or 3 years have a lot of experience compared to people that have 10 years or 12 years, etc. Because they didn't have the same experience with senior developers that come a lot of experience, and they help them to increase very quickly in their career with writing code for legacy code, gathering techniques for refactoring, detecting code smells, as like we said, etc. For me, it's great, because I know that people can come with legacy code and improve the bad quality of legacy code. But when we come for junior to legacy code and you improve that, it's really very, very important.
Yes, we can. And that's an important point. Before we jump further, and nowadays there's a lot of talk about DevX, developer experience, running surveys with your team, DORA metrics, and all of that, and that's really nice. So looking back at this time of my professional life, I want to highlight the snowball effect which making these things did for us. So people were so engaged in the team. Everybody was trying to pitch in more. There was more excitement, more fulfillment when we did something, when we achieved the next milestone and the next milestone, and things were getting better and better. So that feeling and that closeness we had, because we were doing something great. I mean, sometimes you just want to do that. It is beyond the fact that, okay, the business needs feature X and whatever. It's like, what makes you proud, what makes you tick. And we were all, I don't know, shining and just having the really good time. And it wasn't always easy, because sometimes it's hard to change that code. To maybe you make a mistake, maybe, but the energy was so great because of this, because we were taking that code and we didn't throw any away. We didn't say, yeah, this is garbage, let's rewrite it from scratch.
Yes.
We just owned it and started to shape it to the form we wanted to. And like I said, it's one of the most
yes.
the code bases I'm most proud of, even though it's not pure solid, it's not pure I don't know, unit testing.
Yes. But from your point of view, it's better the experience with this legacy code, with to help other developers to improve their career with legacy code and change their mindset. Because I know that juniors that come for legacy code, they are not comfortable with that. They said, okay, it's not a good company, but I need to work with a new code, etc. I have experience with I don't know, Swift UI, etc. with Combine, and I don't like to work with UI kit or no, I don't like that. I try to go further, to go to another company, etc. And for me, having this experience, I think that your mentality of senior iOS developer help a lot these junior developers to improve their career and to work with legacy code without have this doubts or problem or psychological problem with legacy code, that I think developers around the world suffer from that. When you speak about with developers, no, I don't like working with code that come from 5 years, 4 years. No, I don't like. I will go to another company, which is not evident to have a code from scratch. It's not evident. I think that 90% of the code, it's legacy code that come from other people. How we can do with this code? It's very, very. I think that it's very strange that the developers until now didn't understand or accept that. And for me, it's a problem for the community and from all the our domain, that until now we have this attitude that we didn't accept that code. We should accept this legacy code. We should improve it. There are techniques. We should make efforts, make something